Hello again. Welcome back from this short second coffee break. Now it's time for a roundtable. It is about the future perspective for lightweight in the automotive industry. We have today the participants from the Fatigue4Light Project that will give us the insights, will give us the ideas, the perspective of what happened during the project and when they expect it's going to happen in the coming years. We start with a keynote lecture about the new opportunities for materials in the transport sector, and now we'll see how our consortium partners see it. This session will be divided in 4 blocks. We will start discussing about the challenges that electrification is coming. The second one will be about the current lightweighting needs, the situation that the part makers and the OEMs face right now. We will follow with a third block about specifically questions about materials for chassis parts, where the Fatigue4Light focus most of the attention. And we end up with a fourth session about materials for future mobility, more or less like a wrap-up session of what we discussed during this roundtable. So it is a pleasure to have together in the screen. Of course, it's better to have it in a round table, but we have in a square screen. We have the 6 participants today. Myself, Daniel Casillas, I will chair this session. I'm the scientific director at EURECAT. We have on my right on the screen, we have Michele Maria Tedesco. He is the global manager for metals and anti-corrosion at Stellantis CRF. So, Michele, if you want to introduce briefly yourself and your company.
Yes, thank you, Daniel. So I'm the global leader for metals anti-corrosion within Stellantis across all the regions. Just a few words about Stellantis. We are one of the main bigger OEM in the world. We was born in 2021 from the fusion between PSA and FCA. And since we was born, we schedule and we have in mind a very challenge and tough targets. The first one is the decarbonization, because we aim to cut the emission of our company up to 50% in 2030, and we would like to achieve the carbon net zero in 2038. So for this reason, we are pushing a lot for materials, new solution, and all technologies that can support us to achieve this target.
Thank you. Challenging as always. We also have Giorgio Gallo. Giorgio is research and innovation manager at NW. So Giorgio, you want to introduce yourself?
Thank you, Daniel. I'm Giorgio Gallo. I'm the research and innovation manager at MW. MW is a division of Celan Group, and we are making steel wheels. The company is making steel wheels since more than 100 years, so a very long experience. And the group now is part of the Celan Group, and the group is active in metal form. For business is metal forming, and we are now, as MW division, one of the market leader in Europe of steel wheels. And we also act outside Europe in Turkey, South Africa, Russia, and we have joint ventures also in Mexico and around the world.
Perfect. Thank you, Giorgio. We also have in the roundtable Gustav Gustafsson. He is research engineer at Gestam Hartec. Gustav.
Yeah, thank you, Daniel. Yes, I am working at the Gestam Hartec in Luleå in Sweden. I will also introduce the company with some sentences before we start here. So Gestam is a global company with plants and R&D all over the world. And we are working together with many of the OEMs, both with the cars and trucks. We are producing body-in-white chassis parts and mechanisms for the automotive industry. And our mission is to have innovative design and solutions to produce safer and lighter cars. The connection to this project is that we have a very long experience in working with body in white and press hardening of steels. It was actually invented up here in Luleå, this process. But we have mostly worked with thinner materials for cars. But in the Fatigue4Light project, we have the possibility to also develop the process and work with thicker materials to be dimensioned for fatigue and also be used in chassis parts for heavy-duty vehicles. So this has been a good opportunity for us to study this further. Okay, thank you.
Okay, Gustav. Yes, we will talk about press hardening during this session. We also have Remy Mounier. He is a research engineer at ArcelorMittal. Remy, you want to introduce yourself?
Thank you, Daniel. Good morning. Here I'm working in R&D in Mézières-les-Metz in the east of France with a research center with more than 700 people. And I'm also a program manager dedicated to fatigue properties, but also crash and fracture properties. Here in the Fatigue4Light project, our main idea was to provide material dedicated to chassis parts, but also to show that new materials could be a solution for the future of chassis parts with electrical vehicles.
Yes, thanks. Thanks, Remy.
Welcome.
The last in the table, but not the least, of course, is Eric Maklun. He's a senior researcher at RISE. He's representing the technological centers and institutes in this table together with me. So, Eric, you want to give some words?
Yeah, thank you, Daniel. So yes, I'm Eric, and I work at RISE, which is the Swedish Research Institute. We are state-owned, and we are mainly collaborating with academia, industry, and also the public sector. So we are about 3,000 people across 35 cities in Sweden. RISE is organized in 5 divisions, so with quite varying research topics. So it goes from bioeconomy to digital systems to security and transport. I work in the department of polymers, fibers, and composites. So what we do is that we do a lot of testing, verification, and also simulation of those materials. So we work with sustainability, material development, modeling, and also manufacturing. So we have lab facilities for testing and manufacturing. So that includes a large press, which you saw earlier today, which is a quite valuable resource, I would say. And for myself, well, I work mainly within composite mechanics. That is my background.
Thank you. Now we know all our speakers for this one table. So let's first start with the first block about the electrification challenges. The first question, of course, I think it should be addressed to the OEMs we have here today. So the first one is for Michele. We see during the conference today. We see the importance of lightweight and how we can do it in chassis parts. But I would like you to ask about which is the importance of lightweight for internal combustion engines and for electrical vehicles. How do you see the difference in those situations?
Okay, thanks, Daniel, for this question. In the past, we worked a lot with the material supplier and also the stampers in order to reduce the component weight of the internal combustion engine vehicles, because for sure the lightweight was very well linked to a decreasing of fuel consumption and so the CO2 emissions. When we started to think about to electric vehicle, the first thing that we had in mind was, okay, electric vehicle, electricity, we don't care about fuel, we don't care about the lightweight, because at the end we are not burning nothing, but it's not true, because the lightweight and the weight in the vehicle, also in the electrical vehicle, have a great impact on the CO2 emission, because at the end you need the electricity, and the electricity in some cases is green, but in most of cases come from natural gas, or even worse, from the coke. So we have to pay attention also in the electric vehicle about the lightweight, and we have to push a lot on that. Also to limit overall the weight of the car, because the battery are very heavy, especially if you would like to enlarge the range of the autonomy. So how many kilometers our customer can do with the car. And if you increase a lot the weight, you can be in troubles during the crash or during the fatigue performance of the vehicles. Or in some cases, if your internal combustion engine already today is very heavy, with the electrification can overcome 3.5 tons, and you need a new license to drive this vehicle. So
Exactly.
the lightweight is still important also in the electric car.
And maybe also the way that the batteries are allocated in the car, is this changing the requirements for the chassis? Maybe we have to be more focused on that.
Yeah, absolutely, because change completely the dynamic of the vehicle, how the vehicle behave during the crash, for example. So we have to play with the design to assure the integrity of the battery box, because we well know that this is a very crucial component, and if we have some deformation or even some open point on the battery box, we can have the problem of firing and so on.
Yeah, exactly. Fire can be a new problem. And yes, I would like to not have another license for for driving a car. So please go ahead with lightweighting. We will appreciate. So the next question about the lightweighting is just around the chassis part. Chassis has four very important parts that are called wheels, that sometimes we forget that are playing a role, and wheels are our contact with the road and should perform absolutely fine. And here I would like to ask Giorgio regarding this electrification. How do you think the design of the wheels have to be addressed?
The question, Daniel, we have also some change. Still, electric vehicles have wheels, so for now it's good. The component change for sure. One thing is related to, as Michele say, all the heaviness of the battery vehicle, and they are becoming bigger and bigger. So the wheel have to follow this for safety and for ensuring the driving have to be bigger and bigger. So before electrification of steel wheels, medium was 16-inch. Now the medium is becoming 18-inch. So it's getting bigger and bigger, and they're getting flat because of aerodynamics. To increase the range, it's very important aerodynamic. Wheels are getting aero cover. We're going to see inserts to increase the aerodynamic of the wheels and increase ultimately the mileage. We also have other problem, which are the noise. Electric car is silent, so there is not anymore. The first noise is not anymore the engine, but it starts to be the wheel system, a tire, cavity of the tire, and wheels. And for reducing this noise, stiffness is very important. And so requirements of stiffness increase, dimension increase. It's a pretty challenge to design a lightweight wheel. And so lightweighting, it is still important. It's becoming more and more difficult.
Yeah, I agree with you. When you park an electrical car, you really hear a lot of things that you didn't hear before. and we also are taking part of this. I see the point. So yeah, interesting for the future. And about from the material side, I would like to ask to Remy, how is the steel sector addressing these challenges that the electrification is posing into the components and at the end into the materials?
Yeah, there are many challenges. As you said during the first question with Michele, we have several constraints that has increased due to the weight of the battery pack, because you have more constraint on the chassis parts and you have more constraint on the material. We need to develop better material with increased resistance in terms of fatigue performance, but also on crash performance. Because with this sector, we meet these two areas that were divided before. And then we have also an increase in terms of gauge of our products, because by increasing the weight of the vehicle, we need to be able to have the same stiffness on the components, and we need also to develop and to adapt our lines to produce material with secure materials. So that's very increased constraint on the chassis components that were not here before. Because if I come back 2 or 3 years earlier, battery pack was not an issue. There was no question about the chassis for electrical steel. So we are facing many challenges to me in a reduced time. So we need to develop materials that will be able to meet this constraint in the future.
Yes, this is an interesting point. It seems easy that you just simply have to increase the gauge. It's easy, but it's not, right?
It's not.
Hot rolling and cold rolling of steel is not the same.
Yeah.
I understand that you need to adapt first to this.
Yeah, and we have also to face the constraint in terms of formability, because by increasing the strength of our materials, and we have to be able to form them to have the final part, the final design of the component. So we have to meet and to face too many challenges on the subject.
Yeah, I see that. And of course, I would like to also hear the point of view from the part maker. The part makers are using the new materials and asking the requirements for the OEMs. So this is always interesting to be in the middle in this case. So Gustav, please, can you give us some insight about the challenges that you are facing right now in Gestam about this?
Yeah, it's a lot of challenges, but also possibilities for us, because with the electrification, we have to protect not only the passengers, we also have to protect the batteries in crashes and intrusions. So this means new type of products for us. And here, press hardening steel is very weight and cost effective to protect.
Okay. Well, we seem to have some connection problems with.
Okay.
Oh, you are back.
Yeah. All right. Okay. So.
You
okay.
were
Where were I?
Yeah, you talk about the new opportunities for hot stamping. It's possible, and then the question can be: do you still think that? I mean, hot stamping is well established for the bottom white.
Yeah.
Now we will talk now about in the coming minutes about the application of chassis. But do you also think it's important for protecting the batteries?
Yeah, exactly. It is a very good and both weight and cost effective material to protect both batteries and passengers. So I think it's a good solution both for cars and for trucks. And another thing is also with the electrification that we don't have a combustion engine in the car anymore. So it means that we have completely new opportunities when we build the car. So it can be new designs. Because conventionally we have two front rails and the bumper to protect in an impact with the absorbing energy. But when we don't have the combustion engine, we don't have to build this protection around the engine. So maybe we can find new solutions for energy absorptions. So it can be completely new.
This is a new scenario. This is a new scenario. So it's nice to face. We can continue the Fatigue4Light project with a crash and light project with something like this, because you are right. It's the new designs for new requirements. So that's something we should address. Nice. Okay, let's jump to the second block. It's about the lightweight needs, the current lightweight needs that the different agents from the value chain are facing. I would like to start again with a question for Michele. This is about what is the impact of the electrification on the material selection in this case for the chassis?
Yeah, one of the key players during the electrification that we mentioned before is the increase of the weight. So we have to fight with this increase. We have to mitigate this effect, and the material selection play a very important, fundamental role on that, because thanks to the new materials, new steel, new aluminum, or the innovative material like the carbon fiber for the large production of the car, could help us to mitigate this. Together also a good design in order to improve the stiffness thanks to the shape, as well as also a good design as we have seen from the previous presentation done by Violetta, would help us also for recycling of the component. So at the end, the key trends that we see in lightweight and in the selection of the material for the chassis are the performance that have to grow time by time, and also the facility, the possibility to achieve a complex shape, because with the complex shape we can increase the stiffness without increase the gauge of the material.
Yes, exactly. And also you mentioned the talk that Violetta did about the life cycle assessment and so on. And this is another point to consider, right? From the beginning, recyclability and affordability.
Yes, in the past.
Do you think this will give opportunity for new materials?
Will be focused for the new materials and also for the current materials, because this is something transversal. The paradigm in which we are working on is changing. So before we did the car to achieve the performance, taking in consideration the environment, but not so much. Now is completely different. We see a lot of people that do congresses, manifestations, and so on to reduce the impact of the CO2 on the environment, as well as also reduce the raw material usage. And a key way is the circular economy. So we need to dismantle the component and reuse it if it's possible, or at least reuse the material without downgrading the quality, because we spend a lot of energy, a lot of raw materials to have that particular quality, and if we are not taking care, we are wasting the material. So for sure, this is a crucial aspect, and we took in consideration also in the design phase of the vehicle.
Yes, I agree. All the challenges we will face will be about reusing parts, as you said. A foreign part or a foreign component accumulates a lot of energy behind that in terms of the process and the production. So it seems difficult for us to reuse a used part, but it's something that maybe we have to start, right?
Yeah, we have to
start
start
reusing.
with it. Probably will be not something that can be done 100% with all the components.
Absolutely.
Something yes, something no, but we have also to valorize the component for which we cannot do the reuse phase.
Yeah, I agree. From the wheel sector, Giorgio, what the same question, but for the wheels, which are the main challenges in the material selection for wheels?
Yeah, that weight reduction wheels means basically to reduce the thickness of the steel. As also Michele said, if you reduce the thickness, you lose the stiffness, and if you lose stiffness, you get into these problems, of noise, and then you have to modify the shape. And it's very difficult to have a great combination of formability and fatigue resistance. And this is what we tried to achieve in this project. Yes. And so it's like a blanket, and when you throw it, you get to the other side, so you increase the weight and you lose stiffness. You increase the stiffness, but you increase weight. And it is in a safety component, like really is a difficult game.
Yeah, I agree. And from the steel sector, Remy, we hear a lot about the steel utilization during the project and also during the keynote. We know everybody knows that the steel industry is one of the most contributing to the CO2 emissions. So if we use a lot of steel, of course, the industry has to adapt as well to this new environmental scenario. How is the steel industry contributing to the decarbonization of the automotive sector?
In fact, for several years in ArcelorMittal, there is a new brand which is called X-Carb. The idea is to change our process and to use recycled steel in electric arc furnace instead of blast furnace. And then with a massive use of scrap, the idea is to have some kind of green steel. Of course, we have to adapt the process, to adapt the line, to adapt the treatment, but some steels are under development, and more customers requires more and more this green steel instead of conventional one, because they need to have a footprint which is reduced, and by reusing steels, by reusing old components, and by manufacturing new steels from old ones, we try to obtain and to reduce our footprint. But then there will be a key point, which will be to have high performance steels in comparison with green steel, and we will have in the future to meet these two sectors, to have green and performance steels to have a reduced footprint.
Yeah, you mentioned the reuse or use of the amount of the scrap to reduce the CO2 footprint. It seems a logical option because steel is fully recyclable, so we can mix and mix. But of course, when it comes into fatigue, that we know that every minor or every small detail counts. I know that we will work, but this will be the question for the next block, that you will explain how you do it in a fast way, how you benefit from the Fatigue4Light results to ensure that these steels are performing even better than the old ones, or than the current ones. I want to say old. Perfect. I've been talking a lot about steels, but we have in the table, we have Eric, who can give us a perspective about another possibility, that's using composites or using multi-material solution. This is the work that you did during Fatigue4Light. So, Eric, I would like to know your ideas, your impression, your insight about how is the composites in the automotive sector, considering performance and, of course, environmental issues.
Yeah. So yeah, for sure. I mean, composite materials, they have very high specific stiffness and strength. So they're therefore lightweight, good lightweight options materials. I'm talking about structural composites here with either carbon or glass fiber in it. And if we go back a little bit, let's say 10, 15 years, it was a quite big push for composites to be introduced into the automotive because of lightweighting. So they wanted to take down the use phase emissions, and of course, reducing the weight would do that. So quite quickly, there were some challenges, obviously. Perhaps the number one was the volume production of composite parts and their cost. They're more expensive. But then you also get into other things like design complexity, simulation complexity. And since we are talking about, let's say, multi-materials, if you have a composite there, you need to join it to a metal somewhere. And joining of composites is tricky. Actually, you don't want to drill holes in composites, really, if you can choose not to, and so on. But then with the introduction of EVs, or battery EVs, then it was a sort of a little pushback, I would say, for the composites, because with the EVs, as you know, the use phase emissions are not as important as it was before. So it was a little bit step back, and with those issues that I just mentioned. It was a little bit pushback because of some reasons. For instance, also when we talk about recyclability and repair, actually, as well. So there were other things. But now I think it is a little bit shifting back again. So now lightweighting is sort of coming back again in second stage. So we will see where composites will have their place. I think for sure they will have applications. They already do, but also in the future. If you talk, let's say, about full body in white, probably not, most likely not, but some parts where you can sort of utilize the composite properties most effectively. Such applications will also be there in the future, I believe.
Yeah, this is always nice from a material science perspective, the competition between materials, because as the one is going up, then the others are pushing back, and then the other is going down, and then it's really making the industry progress and the science evolve. So we like this kind of challenges.
Yeah, exactly. So I've been here 16 years. So when I started, it was like, yeah, it's going to be composites everywhere.
It will be.
But after like 5 years, no, it's not. And now it's sort of, I think, coming back a bit again. So, and actually the last 20 years, the manufacturing, the automation of composite manufacturing has been, it's much better. It gives more repeatable quality and so on. So a lot of efforts and research has gone into it, but
yeah. I agree. I like this kind of competition. It's always interesting. The last question for this block is about our part producer supplying and using materials and solution. The question is for Gustav, because hot stamping, we know it's very implemented in body and white solutions for crash-resistant applications and so on. What do you think are the new developments that hot stamping can produce or can give to the electrical vehicles?
Yeah, sorry, I think I lost the connection again. So
the connection is not too good. Yes, no. Which are the new developments that, from the hot stamping perspective, can help the development of electrical vehicles?
What we have seen lately with the car manufacturers is that they demand larger and larger parts to decrease the assembly time and speed up the production. And here Tesla has been in the front using the giga castings of aluminium, for example. So we have to compete with this, and aluminium may not be the best solution when it comes to recyclability and also fatigue properties. I think it's quite difficult to to characterize the fatigue properties in a casting, for example. So to meet up this demand, Gestamp has also moved towards producing larger parts for the body in white. We call it the giga stampings. So we are producing large panels for doors, single door rings and double door rings, for example, but also one-piece floors and also the roof. So decrease the number of assembling parts for the manufacturers.
Yeah, this is decreasing the number, and then maybe assembly will be a little bit challenging again. But of course, the saving in logistics are clear in this sense. So that's interesting. Yeah, we go into the third block. It's about material for chassis parts. We can talk here about the developments that the partners achieved during the Fatigue4Light project. And because it's materials, I'm going to start with Remy. Because you said it's going to be a lot of changes due to electrification. There are new still coming. As I suggested before, the amount of scrap is increasing. So fatigue is not a fast technique, not a fast test. It needs a lot of time and means. And during the project, we developed some technologies that were also explained by Serge during this conference. But I would like to know, Remy, you from the lab at Arcelor, how do you think you can get results in a short time that everybody is needing?
Yeah, it's a very good question because for test we need material and we need time to produce the material, and it's complicated to produce a complete coil because we have to face to every step in the production. But in the end, we have to do some tests. It's about fatigue, but also all the other tests that are required by customers. For chassis parts, of course, fatigue is one of the key challenges, but we have also to deal with the assembly to be able to weld the structure and so on. So we want and we are developing more and more specific tests dedicated to these points. The idea is to reduce the duration of the test and to have more technique tests, maybe more complicated to develop, but that will bring us more information than conventional ones. And for this purpose, for fatigue specifically, we have developed for many years a test called self-fitting test, and the idea is to have more intelligence and to determine what are the fatigue properties of the steel. Because when we are cycling under cyclic loading, a material can heat, and if we are able to measure the heat, we are able to determine the fatigue properties. And then by reducing the time for testing, we can reduce the time for the development of a new material. And one of the material of the project here in Fatigue4Light, which was HR 980, the multi-phase steel, which is still under development, and we have massively used this technique to be able to have a reduced development time for this material. So it's one of the key points. Reducing the time of test will permit to have more time to adapt the process and to be able to provide a good material at the end, which can be used by customers.
Yeah, we need data. We need data to model the forming process, to model the fatigue. We also need data to assess that the plants are working steadily and that this change in the scrap content or steel production is okay. So we need data. And did you have an idea about this method that you're using? How was the reduction of the development time you get thanks to this?
It's complicated because we know that in comparison from fatigue conventional test, we are reducing the total time from 3 months from the preparation of the specimen to the final fatigue ascent curve to several, I could say so, 2 weeks, the time to machine the specimen and to have a fatigue response to be able to determine what will be the fatigue properties at the end. But as we are facing to several steps, I know that we won several months during the development of the material, because we were able to say soon in the process, okay, here we have issues, we need to adapt the process because fatigue properties are not good, or here we have a good possibilities with this technique. So several months on the development of the product is crucial for us.
Yeah, no, that's really impressive. I mean, time is money in this case, and decisions should be taken fast. So yeah, and also during the project we did different fast techniques, and we really see that they're really working well and they're really effective.
Yeah, the
people can use it.
Yeah.
Yeah. Well, about materials now, come back to Eric. About composites, please, can you give us some words or some reflections about the fatigue performance that you see in the materials you test during the project?
Yeah, I can do that. Well, so for composites, actually historically, fatigue wasn't really a big issue. It was, and I guess the reason was mainly because the ones doing simulations back then was mainly within aircraft, and they have no growth criteria. So it was, they were testing and everything, making sure everything was fine, but in terms of modeling in detail, it wasn't really as important, let's say. But then with the development of large wind turbine blades and then also automotive, then fatigue became sort of important again. Some of the challenges are, of course, that this material is anisotropic. So you have different response, different stiffness and strength in different orientations in the material. And the damage itself, the damage development. So before, let's say, ultimate failure, you have a lot of damage that grows in your material. That is quite complicated type of sequence of damage. So typically it starts at a micro scale. You can have clusters of fibers and so on. You have a small defect, micro scale defect, and cracks, matrix cracks grow. They in turn can trigger delaminations, debondings, and fiber breaking in the end. So it's like a sequence of mechanisms. And to capture that accurately in modeling is challenging, to say the least. And I mean, on top of that, you also have variable material properties. You have a material that is depending on the environment in the way that, let's say, temperature and humidity is also influencing. So if you put everything on this on top, then modeling becomes tricky. I mean, we have a pretty good understanding about the mechanisms, and we do modeling, but to transfer that to do modeling on a large scale, because we know it comes from the micro scale, right? And it grows. But how to do it efficiently for larger structures, that's an ongoing challenge for sure. Software tools and models are becoming better, but it's still very much the holy grail. So if you have, let's say, an efficient large scale modeling approach, then that's which doesn't require, let's say, supercomputers to run the simulations, because they tend to be quite heavy. So and then finally about testing. So you need to do a lot of testing for sure, because of the variability and so on. But testing composites, you would know that, for instance, your test results aren't really material property. It depends on the geometry of the specimen. It depends on also, let's say, about the frequency of test. For instance, if you want to do rapid testing, then you have self-heating in the material, which affects the properties as well. So there are challenges in both testing and simulation, which for sure is ongoing research.
Yeah, I agree. In fact, Sergi Pereira did some preliminary tests on composites with the stiffness method. The results are promising, so maybe we can help you in this huge task about testing, and maybe also in the future, or in the coming weeks, the artificial intelligence algorithms or new strategies for surrogate modeling maybe will help us for this scaling up from a specimen to large components. So we need the help. We need the help of some other multi-technology approach.
Yes.
Great. Now, Gustav, please, we're going to materials. So talking about chassis parts, talk about the gigastructures is an interesting trend. Why we should, or why you recommend to use hot stamping for chassis part compared to the cold forming part?
Yeah.
What would be the advantages of using hot stamping?
I understand your question. As we saw this morning, Henrik from Scania was talking on this topic a little bit, and if we have good condition in the steel with good surface quality, then we have this relation between high strength and fatigue strength. So comparing a high strength steel with a yield limit of about 1000 with a cold forming steel with a yield limit of about 500, we see the potential of using this kind of material. So this means that we can decrease the thickness and decrease the weight if we have this working properly. And also with hot forming, you have a very good formability when you do the stamping, because you form it and quench it in the same time. So you have the possibility to produce quite complex shape in just one stamp, compared to cold forming, where you do it in several steps after each other. And also you don't have the problem with spring back using hot forming technology. But of course, we have to solve this risk with value quality of the.
So somebody can ask you, okay, but the martensite is really brittle, and then it will fail, and the fatigue and the microstructure will be fully martensitic in this steel. So, but we see that we can improve fatigue resistance.
Yeah. We have seen in the project that using, for example, shot peening has a very good influence on the fatigue properties. So, but you have to be aware of the risks.
Exactly, you have to be aware of the risks. Yeah.
To ensure that you have good quality of your products. So.
Yes, this opens a new possibility for applications. And martensite, if you treat well the martensite, if you don't overload them, martensite is an excellent microstructure, very homogeneous and fine. Yeah. Giorgio, now moving from parts to the ground, to the wheels. In the Fatigue4Light, you work a lot in testing and also using or also assessing the effect of forming on the fatigue and so on. It's relevant for wheels. I would like to ask you to explain to the audience what are the aspects of Fatigue4Light project that was really important to address or to meet the targets of material for a wheel.
Yes, we did basically in Fatigue4Light trying to make a material replacement, which is not so easy in wheels with a very mature component. You can think that dual phase grades, which are one of the reference for the disc, is there since the end of the 90s. So it's worked really well, but after 20 years, we really optimize it. So we wanted to look if there is something else for maybe particular application to try to increase even more the lightweight. And forming is really key, as Erik Olsson said this morning before presentation. Forming and fatigue are really connected. So C graded on the paper is better than dual phase grade, for example. Then after forming, it's not anymore. With the project, we try to play with the technology of forming and treatments by shot peening, as Gustav said before, to tune them, to find the correct combination of forming and shot peening to achieve by the result. Each grades react to fatigue after forming and after chopping in a different way. So in a different way. So it's testing was a thing. First, we tried with this little specimen that Eric showed, and then the best grades we selected with the specimen. We tried directly on wheel. Is consuming and also effort consuming, but at the end we think we reach a good final 10% weight reduction, which is for the wheels is pretty good.
Yeah, I agree. It is. Michele, the last question of this blog for you, because we're talking about the going to be new materials, new steels. Also, Remy promises to give results in a fast way and so on, because you need it, right? From the automotive industry, the OEMs need to develop a vehicle, and during the Fatigue4Light we address this rapid fatigue methodology. So I would like to ask you, what is your opinion about the impact that simulation and the fast fatigue characterizations may have on the vehicle development?
You are completely right, and I fully agree with what Remy said before. We need the data to perform the simulation, and due to the development phase of the vehicle is decreasing time by time, we have less years to develop the new vehicles. We have to run fast. For this reason, a very good simulation can return us very good results, and so at the end, with one or at maximum two adjustment, we can release the final shape of the component, the material, and so on. So it is crucial for us to have a data that predict very well the behavior of the component, because these help us to reduce the timing. And as well as we need also the data. Sometimes we face some problems when we have a new material that we have in mind to implement on that specific component, but at the end we don't have the fatigue data. And when we asked to our design team, okay, please wait 3 months to perform the characterization, they said us, no, you are crazy. We don't have 3 months to wait. We need to release the component in just a few weeks. So goodbye new material. We will use the material that we already used in the past, and we lose an opportunity. And now that we are running more fast, this can happen more often. So for this reason, we have to reduce the timing of the test. So I'm fully in the same page of Remy, and I will very appreciate if we reduce the fatigue time, because this is a roadblock for us sometimes. And these also give the opportunity to introduce new materials.
Yeah, you know, people like numbers and KPIs and so on. Do you think you can say more or less which is the percentage of time reduction that you can get if you implement this fast fatigue modeling and experimental technologies?
We can expect around 10% of reduction in the time, because we can avoid to make some adjustment, because with very precise data, we can also decrease the safety factor and go straight to the point, to the final point that we need.
But the 10% is nice, but I think you have still to run. Your colleagues will still you do it now and now. But I think that with the solution we develop and the commitment also of the full value chain of the industry, I think we can reduce this developing times significantly. Yeah, interesting. So now we're going to close the round table. We have the last block that it's about the material for the future mobility. Is more or less like wrapping up and making like a short conclusions for all of you. I can start with Eric again about the short expectation about solutions in the future, especially for the multi-material solutions, is the ones that we develop in the Fatigue4Light project.
Yeah, so that material we were working mainly was with a hybrid type of material, which has aluminium facings and then composite core, you can say. Yeah, I think it can probably be, I mean, it shows some promise in terms of lightweighting. We managed to cut the weight by, I think it was 20%. But immediately, I mean, you're running into other problems as always. There's nothing, it's not a straight way forward always. It's then you need to go to the recycling, and then now you have different materials and so on. That can be, we showed it's possible to separate rather easily that type of material that we had there. But yeah, but if we look at automotive components and composites, I mean, for sure, if you're going to have volume, it needs to be basically anything that can be pressed, or I mean, at least, I mean, autoclave type of composites, and we didn't do it in this project, but another interesting approach could be, and it is looked into, is to use also thermoplastic matrix composites with carbon, for instance, which has good properties, strong, stiff, and so on. And with the thermoplastic, you have a bit more options in terms of recycling or reshaping or joining, like welding, for instance. You cannot do that with a thermoset.
Or maybe Eric, the new bitumeric materials can be a possibility, not for tomorrow, of course, but something that maybe can help us to solve this recyclability and mechanical performance issue.
Yeah.
So we will be aware of everything. Thanks, Eric, for your insight. The other second question in this block is for Giorgio. What do you see in the coming years? Very soon, how do you see that we will?
Yeah, for us, carbon footprint and recyclability will play a strong role, as I said before. You know, so Eric is saying now for the hybrid version. We have also hybrid version of wheels, and it works well because you have the best of both material. But as soon as they, as Eric said, as soon as they are really easy separable and easy recyclable, you can run into problems. And steel is as Remy says, it's a clear roadmap for decarbonization. And I think between aluminum and steel, which are the main material for wheels, now steel has an advantage, a lower carbon footprint, 1/4, but both aluminum maker and steel maker are working hard to decarbonize them. So whoever comes first with a fully readily available, widely available, zero CO2 material, it will be very important in this moment.
Yeah. Not again adding LCA, good LCA to all the properties, so making more difficult for the material engineers. But life is that is. Yeah, Gustav, the question for you in this blog is about following the keynote we see in the beginning and now the results you'll be discussing during the project is what are the next steps towards manufacturing press hardening components for the truck industry that we see that is a sector with a huge potential in lightweighting and CO2 decreasing impact.
Yeah, what we have learned in the project is going from thinner materials to thicker materials. We have some challenges because in the project we produced this demonstrator for the cross-beam member. And we have seen that we have good properties in most of the places, but for some places of the beam, we have less hardening of the material, for example. But this should be possible to solve. But it's a larger challenge when you work with thicker materials compared to thinner, because in the forming process, you will have some thickening and thinning of the materials. But for a thin material of maybe 1.5 millimeter, 10% thickening is not so much in millimeters, but 10% in 6 millimeter thickness, that gives some gaps and embed a heat transfer from the blank to the tool. So you have to be very to do this very properly and make use of numerical models also
Exactly, numerical
to
modeling
to predict the heat transfer and the hardening of the material. But normally we also do this compensation of the tools.
Exactly.
That's nothing we did in this research project. So.
But it's something that with the knowledge about the modeling you have and the tooling capacity and expertise is something that can be done.
Exactly. And another important thing is, of course, the fatigue properties. And I think here we have to work together with the OEMs to establish the tests that they should pass, and both on.
Yeah. And again, do it fast. We can do it fast. We have the possibilities of doing a fast fatigue test, so we will use that. Yeah, the next question is for Remy. Just as summarizing your work in the Fatigue4Light, what do you think that the Fatigue4Light project helped in the introduction of the new steel grades in the different applications?
Yeah, to me, there are two main aspects. First, I would say that according to what Michele said, the time dedicated to project development for new vehicles is very, very reduced. And as shown in this project, to me, we need each other to be able to respect the time dedicated to project development at the scale of the material, at the scale of the data. It can be fatigue data, it can be crash data, it can be mechanical properties, and so on. Then we need simulation to be able to validate the model and to be able to reduce the time dedicated to prototyping and so on. And then we need a validation. And according to this, all range of expertise, we need each other. And at the end, we need also to industrialize the solution, to be able to form the part, to test it, to validate it, and the whole process is very time consuming. To me, the second aspect would be to be able to provide more advanced material data, because we perfectly know that an appropriate adequate simulation will be able to reduce the time dedicated to project development. And to me, it will be one of the key points for the future to be able to provide material data card in a reduced time, but with more advanced information than the one we conventionally are able to provide. It could be on the model, it could be on the data, to be able, for example, to deal with the influence of the plastic strain and so on the fatigue properties. But I think we will be able in the future to deal with this aspect, and it's very challenging for the future years.
Yeah, I agree. Thank you, Remy. And now the last question of the roundtable is the easiest one. So can you give us the material composition of the body white and chassis for the next 5 years?
Thanks, Daniel. Yeah, it's very easy question. You're right. I'm just supporting what Giorgio said before. Today there is not a final description of what will be the future, but for sure is a race. And what kind of material will arrive before the others to be fully decarbonized will be the material that will be larger, implemented in chassis and in body white. Steel maker, aluminum maker, and the other metals maker are working a lot in this decarbonization. They are proposing us some interesting things. We have to continue to work together, and the final decision will be linked with the costs for sure, because we have to be competitive with the new emerging OEMs, especially in China, in which are very aggressive on that. On the CO2 emission at the global vehicle, not just looking at the single component, but overall the car, And so also the third one is the autonomy in the range, because this is one of the main scare of our customer. Stay in the on the road and see the battery level near to zero.
Yeah,
so
yeah.
they're scary to stop their travel.
Yeah.
So these are the three main aspects for which we have to work on, and the lightweight and new material play a fundamental role in each of these three. So there is not the final ricetta, but we will see. Time by time, we will adjust our trajectory in order to achieve the goal.
Yeah, I said it's a simple question because you can answer whatever you want because the future will change. I always when we talk about that, I always remember that this is a nice presentation from the late 90s. They forecast the materials for the coming vehicles. No words about high strength steels. No words about carbon fibers because the technology changes very fast sometimes, and it's difficult to see it. And now what I see is in the last 10 years, it was more stable, more or less, the scenario. A lot of high-strength steels, but now with all these sustainability issues, I think we are in front of a new scenario. And for all of us that are here in this round table, it's interesting because we work in materials and we work in automotive. So definitely we will meet more often in the coming years and discuss about this.
Absolutely, we need all of you researcher, tier one, metals producer, because we have to work like a team to find a solution.
Exactly. This is how in Fatigue4Light was. I think it was a very nice experience working all the actors for the value chain working together. So well, I just want to close this roundtable with this kind of invitation for keep in touch and discussing, and hopefully in 5 years we can meet again and discuss what is now and what it was five years ago. So thank all of you for staying with us, for sharing your ideas, your thoughts, your experiences in Fatigue4Light. Of course, we are in touch and we keep on collaborating. So now we move to the closing session of the seminar. Thanks again for staying with us and keep in touch.
Thank you.